Good day, viewers. You are welcome. How to solve these nice algebraic equations? We have root x minus root y equals root 11. We are interested to find the maximum value of x over y. And where x and y, both of them are members of natural number. So, to solve this, we are going to be considering transferring root y to other sides so that we have root x equals root 11 plus root y. So before solving this problem finish, so we can try it and drop the answer in the comment box. But this is the best method, I think. Here we have root x equals root 11 plus root y. By taking the square of both sides, we have x equals root 11 plus root y raised to the power of 2. I want to make x the subject of the formula, and I want to make y the subject of the formula as well. When we expand root 11 plus root y, we are going to have 11 plus y, then plus 2 root 11y. So after expanding this, I want to make y as well the subject, and I want to make x the subject. Let's say I replace y in terms of k. If I let y to be equals 11k squared, but k here also is a member of natural number, then we are going to be replacing every single y here with 11k squared. So here we have x equals 11 plus 11k squared plus 2 multiplied by square root of 11 multiplied by 11k squared. Then we have our x equals 11 plus 11k squared plus the whole of this one, it becomes 2 root 11 times 11, that is 11 squared multiplied by k squared. But according to this root, the root will be affected. We cancel this one and this one. When it cancels this square and this squared, we are going to have 11 plus 11k squared plus 2 into bracket of 11k. And then we have x equals 11 plus 11k squared plus 2 times 11, that is 22, then k. From here, to make x the subject of the formula, what we are going to do is, if I factor out 11 from here, here becomes 1 plus, here is k squared, here is 2k. And the whole of 1 plus k squared plus 2k is a quadratic, which is given as 1 plus k all squared. So if this gives us x, and we know our y already as 11k squared, then we are going to divide it and look for the maximum value of x over y. And here we have, so when we divide this, we are going to have x divided by y equals, we have our x, this is our x, and here is our y. So we have 11 into bracket of 1 plus k squared divided by 11k squared. Then if 11 cancelled 11, we have 1 plus k divided by k all raised to the power of 2. So on getting this, we can also divide this as 1 divided by k plus 1 raised to the power of 2. and this is x divided by y. Well, we have to understand here that we have 1 over k, as k here is not equals to 0. So therefore, the inequality is 0 less than 1 divided by k, and 1 over k is less than or equals 1. But we have to get 1 over k plus 1 from here. It means that if we remodify this, we are going to have 0 less than 1 divided by k plus 1, then less than or equals to 2. What I did here is, if I take 1 here, we are going to have what we have above. But what I need is 1 over k plus 1, which is this. And for every single thing that we have here, so this shows that the maximum value will be 2. If the maximum value is 2, then we are going to have the max of x divided by y. Since we have made it to be 1 over k plus 1 squared, then this becomes 2 squared, and 2 squared here equals 4. So showing that the maximum of x over y equals 4. So this is how to solve this. Thanks for watching, and see you in the next video. Never stop learning. Bye bye.